All right, let's pull back the curtain on the tech you use every single day. We're going to talk about the invisible engine that, well, makes pretty much everything possible. Seriously, just think about it for a second. What's really powering the apps on your phone? The games you can't put down, or the AI that you're probably talking to right now? We hear so much about Python and JavaScript, but what's actually making it all tick, at the deepest, most fundamental level? Well, if you could just peel back those familiar layers, the user interfaces, the Python scripts, you'd find something else entirely. There's this incredibly powerful, high-performance foundation running underneath the whole show. And it runs on C++. Yeah, that C++. And look, if you're thinking, wait, isn't that some ancient, dusty language from the 90s? Just stick around. Oh man, are we about to show you just how wrong that idea is? Okay, so let's properly dive into this concept. We're calling it the invisible engine. And honestly, a great way to think about it is like it's the dark matter of the computational universe. It's absolutely massive. It's literally everywhere, holding everything together, but you almost never, ever see it directly. So, where is this engine the most critical? Well, let's start with the biggest thing happening in tech right now, AI. I mean, everyone says Python is the language of AI, right? And they're not wrong. But that is maybe half the story. This right here, this is the perfect way to picture it. Python is like the steering wheel of the car. It's easy to use, it's comfortable, it lets data scientists prototype and steer the project with ease. But C++? Oh, C++ is the raw, roaring engine. It's the thing under the hood doing all the incredibly heavy lifting. So why is it the engine? Well, it really just comes down to one thing: pure, unadulterated performance. Think about it. To run these gigantic AI models today, you absolutely need C++'s ability to manually manage memory. That's what keeps the server costs from going to the moon. You need it to talk directly to the hardware, to squeeze every last drop of performance out of those GPUs. And this is a big one. You needed to go in and fix the slow, kind of almost right code that AI itself often spits out, turning it into something robust and lightning fast. Okay, but of course, you can't talk about high-performance languages today without someone shouting, "What about Rust?" And that's a fair question. This quote here really nails the answer. It's not about one being better than the other, it's about the right tool for the job. Rust is amazing for new, greenfield projects where memory safety is everything. But C++, it's still the undisputed king in domains where you need that super fine-grained control, and just as importantly, where there's already this massive, mature ecosystem built around it. All right, let's shift gears a bit. We've been in the kind of abstract world of AI infrastructure. Now let's talk about something way more tangible: the open source tools that are putting just unbelievable creative power into the hands of millions of people. I mean, just look at this. Over 500 people. That's 500 individual developers who contributed C++ code to a single release of the Godot game engine. That's basically a volunteer army that is as big, if not bigger, than the teams at some major corporations. It's wild. And these volunteers, they're solving real, nagging problems that affect gamers everywhere. You know that feeling? You get a brand new, super fast monitor, you fire up a game, and suddenly, moving objects have this weird, stuttering visual glitch? That's a thing. It's called physics jitter. And it happens when your fancy monitor is updating faster than the game's physics simulation can even keep up. And here's where the magic of open source C++ comes in. One developer, just one person, got so fed up with this jitter in their own project that they just dove straight into the deep end of Godot's C++ engine code, figured it out, and engineered a solution that now benefits everyone. That's the whole scratch your own itch philosophy in action, and it's what drives so much of this incredible innovation. And this revolution isn't just happening in gaming. Take Blender, the go-to 3D tool for so many artists. It's also powered by C++. We're talking about features that not too long ago were exclusively for Hollywood VFX studios with million-dollar budgets, things like next-gen real-time rendering and professional light linking. Now, they're being built by this global C++ community and just given away for free. It's amazing. Okay, so we've talked AI, we've talked creative tools, but now we're going to raise the stakes a lot. Let's move into the world of critical systems. Places where a software bug isn't just an annoyance that makes you restart an app. We're talking about places where failure is absolutely catastrophic. Take SpaceX, for example. In space, you have cosmic rays that can literally just flip a 0 to a 1 in a computer's memory. For a rocket, well, that's disastrous. So their solution is this brilliant actor-judge system, all written in C++. Here's how it works. They have multiple computer cores all running the exact same flight code at the same time. Then a judge system looks at all the answers. If one core gets zapped by radiation and gives a weird result, the judge just says nope and votes it out. It's incredible. And that level of hardcore reliability, it demands the kind of predictable, down-to-the-metal control you can only really get with C++.
Okay, so from outer space, let's jump to Wall Street. In high-frequency trading, we're talking about a world where fortunes are made or lost in literal nanoseconds. Here, slow code isn't just bad, it's your absolute worst enemy. In fact, the engineers there have this amazing name for systems that aren't optimized to the gills. They call it the land of despair. So how do you escape this land of despair? It all comes down to something that sounds simple but is incredibly hard. How your data is laid out in the computer's memory. The slow way, which they call pointer chasing, forces the computer's brain, the CPU, to jump all over the place hunting for the next piece of data. It kills performance. The fast way, which C++ gives you total control over, is to pack all that data together in one perfectly straight line. That way, the CPU can just slurp it all up in a single lightning-fast burst. It sounds like a small detail, but it's a choice that can make a multi-million-dollar difference.
So we've seen this invisible engine everywhere, right? Powering AI, creating art, launching rockets, trading stocks. But what does all this mean for you? How do you become one of the people who actually builds and maintains this critical foundation of our world?
Well, you could take some inspiration from a guy named Andreas Kling. This is an incredible story. He started building an entire operating system, Serenity OS, from scratch, basically as a form of therapy. His journey just goes to show you that some of the most profound, meaningful work can come from just following your own personal curiosity. I love his mantra, effort is a universal amplifier. It's so true.
And you know what? That kind of effort really pays off in the real world. In today's job market, forget the resume for a second. A GitHub profile showing you've actually contributed to a big C++ project, that is the new credential. It's what people are calling an anti-lead code signal. It proves you can do the real work, navigate huge, messy code bases, and collaborate with a team, not just solve some abstract puzzle on a whiteboard. And look, here are some amazing places to start. There are real pathways here for every skill level. If you want to get into game dev, Godot literally has a junior job pipeline to help beginners get started. If you're fascinated by AI, you can dive in and contribute to the C++ backend of PyTorch itself. Every one of these is a gateway, a way to become one of those highly sought-after engineers who builds the invisible engine. So there you have it, the powerful invisible engine that is driving so much of our modern world. It's not built by some single company, it's built and constantly made better by a global community of passionate, dedicated engineers. And right now, it's waiting for its next contributor. The only question left is, will that be you?